Hi guys, let's do the Leetcode. Um, I wonder what 190, I guess 190 reverse bits, and it's, a, it's kind of interesting problem. What happens is that you're given a 32-bit unsigned integer, and you have to reverse the bits in the integer. This unsigned integer. So, for example, he gives you this binary representation of a 32-bit unsigned integer, and it says, well, if you reverse the bits, you would see that these are basically reversed. As you can see from here, we expect 0 0 1 1. So that's what we are seeing here on the right side, sorry, the left side, 0 0 1 1. So now let us try to see how we can attack this problem. And so I guess he gives more examples, but at this point it's very clear what do we need to do. And this example, as you can see, is 0 1, which is 1 0, and then everything else is 1 1. So basically it's almost like reading the thing from right side. Like for example here, you read it from the right and you go left. This is what you get exactly when you read from here from left to right. So, so then he says there are some other notes. Note that in some languages such as Java, there is no unsigned integer type. In this case, both input and output will be given a signed integer type and should not affect your implementation, as the internal binary representation of the integer is the same whether it is signed or unsigned. Now we are not going to do this in Java, so I guess I don't even care about that. So let's do it in C, which is what I've chosen here, and it's a very good interesting problem because in C actually lends itself to these kind of problems, bit to bit manipulation, because it's a low level languages at the operating system level, kernel level, device driver level. So let's do it in C. What we're gonna do is our approach is going to be that what if we had a number 32 type, and we call it reverse, which is the reverse bits, and we assign it to 0. And then what if I say while n, all we do is we make, imagine we had to do something like this. We left shift the output, or the reverse as we are calling here, by 1, and maybe we should call it reversed bits. That kind of makes it easier. Reversed bits, alright, there we go. Reversed bits. So we left shift that, and then we check if, so we have basically made a space in reverse bits for our next bit to be put in. And then we say if n and 1, which is to say that, hey, the rightmost bit in n is set, and if it is, then we know that we need to use this bit in our reversed bit. And we just use the OR operator, and we say, okay, that's cool. And once we have done that, all we need to do is we need to right shift n by 1. How is that? And in the end, we can return reverse bits. Do you think this would work? Are we making any logical mistakes? So let's see, let's try to run this code. And we have a wrong answer. Why we have a wrong answer? Because we didn't reverse the, let's see why that is the reason. So let's do this. How about if we give it a number like, imagine you give it a number like 10, or so let's do what we can do is you can set that to 1, but there, okay, let's set this, everything else I want to give it a number like 1, and everything else I want it to be, all other bits I have to set them to 0 to make it 1, except the rightmost bit. So this is very cool in Leetcode. It lets you construct your own test cases. Which is pretty awesome. So now let's try to run, and he says that is wrong because we, so okay, I guess what's going on, I see what's going on. What's going on is that we are reversing the actual bits of a, not the complete range. We are not considering the fact that a uint32 would have 32 bits. We are only reversing the actual bits. So let's see, let's try to change the test case to see that that indeed is the case. Suppose I gave it 10. Now you see, ideally you would expect 0 to go here, which is, and then 1 after that, so like one huge number. But if it is only reversing the actual bits, you would get, instead of 10, you will get 01. And that's indeed is the case. As you can see, we got 01 here, 10. So let's try one more case, and let's say 11. Now you see, ideally you would have expected 11 to go to the end, and then everything else to be 0. But because we are only reversing the actual bits without considering the complete width of that particular variable uint32 type, what we would get is, if you reverse these bits, you will still get 11, and that, let's see, and that indeed is the case. Now for example, if you have something like, imagine you have this is basically hex B or decimal 11, and if you reverse the way this our program is working, instead of making this go all the way to the leftmost bit, the most significant bit, it's just reversing the actual bit. So what would happen is you would end up getting 1110, which is 13, because 1100 would be C, hex C, and 1101. So 1101, that is the number after C, which is decimal 13, basically D in hexadecimal D. So let's see that. And that's absolutely the case. We are getting 13. So basically, how do we change this? This is not what he wants. He wants the reverse bits to consider the complete range for that particular type, which is in this case 32-bit unsigned integer. So if we were to rewrite this implementation, we would, let's see how we can do. So what our approach should be that we start with as usual here, and then we say for int I equal to 0, I less than. Okay, so now let's take the fact that how many integers this thing will have. So this thing will have, so what is the total number of bits? So uint 32-bit. So let's say int, because I think integer is enough to fit in that. So int, suppose we define uint 32 bits, which is size of so what is it? Basically it's if you think about the size of n, this will give us the size in bytes, remember, mind you. So basically it should be multiplied by 8 to get the number of bits, and this basically is the total number of bits in our, maybe we don't need this here. How about that? So that's the total number of bits here in now. So uint 32 bits is equal to 32 here, basically because size of n is going to be 4 times 8, 32. Now for int I equal to 0, okay, so now let's do that. So we'll run this from 0 to 31, which is the index for each of the bit. What we're going to do is, the idea is to see if the ith bit is set. And how can we do that? We can do that by saying if n1 left shifted by I, how is that? Then we know that the ith bit is set. Then we say the reverse. Now if ith bit is set, we should know that this would end up being going to the, now let's take the case here, let's take this example here. If for example the 0th bit is set, then in the reverse we should have 31st bit set, and if the first bit is set, then in the reverse we should have 30th bit set, and similarly so on and so forth. So if that is the case, how do we construct that kind of thing? So we can say that means 1 left shifted by uint 32-bit bits minus 1, because we have 0 indexing, so we are going from 0 to 31st, and this whole thing has to be divided by I. Subtracted by I, because see, when I is 0, then you get 31. If I is 1, you get 30th. And so that kind of should fix this thing. So reverse bits equal to, let's see if we made any mistakes. So this is all good for, okay. And if at the end of it, we just basically return the reverse bits. Now, to see if this code works, we first have to actually if-def out. This is pretty cool in C. You get to if-def out code wherever you want. It's kind of getting rid of the whole block of code in one shot. And I love that feature of C. So that one is, I have commented out. We have the new implementation of reverse bits, and see that that works. So let's do a run code. He's saying that run left shift of 1 by 31 places cannot be represented in type int. So I guess we have to do some typecasting magic here, and that was kind of, I had to actually, once I had to Google this thing. I was wondering what's going on. So okay, so now we have a problem again here. Funny that it gave the problem on the later line first. So u int 32 underscore t, there you go. So we have typecasted 1 to be a u int 32 type. So let's see. Wow, so that works. So now as you can see, this time instead of only reversing the actual bits, which is what this previous implementation ended up doing, it actually reversed bits in the sense that on the whole 32-bit range, it basically made it possible that you have a reverse representation of those bits. So as you can see, you would expect 1, 1, 0, 1. So you see 1, 1, 0, 1, and all of them are 0. So that's what is basically was required, but I guess we got it wrong first time. But that's fine. That's how the coding works. It's always iterative process. You have to, in coding, all you have to do is always make mistake. Try to start making mistakes, and then you go from trying to get it right. You never get it right in the first end. It's like science. You always have to do trial and error and hit a lot of dead ends before you actually get the solution. So let's do a submit and see if actually passes more test cases. Wow, so it's basically saying it's faster than 100% of C online submissions, which I wonder how many people actually did this problem. But basically it is working fine. So there you have it, your reverse bits implementation in C, Leetcode, I think it was 192 or 190 or something like that. In any case, I hope you had fun exercising your brain, and I had fun implementing or trying to basically understand what is going on in this problem. And I wish you guys all the best in your software job hunt journey, and I hope to see you in the next slide. But until then, keep coding. Goodbye.